So, Alec, what did we say we were going to use?
Tangent.
Tangent, right, because you have an angle and a side and another side. So you want to think about the trig function that uses the side opposite and uses the side adjacent, which is tangent. Okay. So tangent theta equals opposite over hypotenuse. Thanks for the S that looks like a 5, Kelly. No, I'm kidding. It's my fault the S looks like a 5. S is good for short. It is bad for looking like a letter, though.
Oh, they both look like 5.
Yeah. Yeah. Okay, so I have a variable on this side and I have a variable on this side. So I'm good, right? I can start to differentiate with respect to what?
Theta? Or, is it?
Well, yeah, so we need like a d theta dt in the problem. We need a ds dt in the problem. So we're going to differentiate with respect to t, always with respect to time.
Oh, that's right. Secant squared theta theta dt.
Awesome, yeah. Yeah. 1/5, and then what?
ds dt.
Yep. These are good at that already. Really, really good. Okay, so find the SDT when. All right. So the SDT. Yeah.
Multiply by 5.
Great. So, oh, how about if I do this? Okay. All right. So the SDT is all that stuff. Now this is why I said, notice there's not actually like a theta in the problem, and there could have been. You know, for some reason, if we were doing a chain rule thing, and maybe it was secant of theta squared instead of, you know, a secant squared thing or whatever, then you would have to multiply by 2 theta. And in that case, if there was a theta itself, you would have to have theta in radians, okay, to plug it in. But theta's in degrees, so we're good. All right, so we need 5. And then we're going to need to figure out what the secant of 30 degrees is. And we're going to square it. And we're going to multiply by d theta dt. And there is a reason for this. I'm leaving out the radians. Go ahead.
I was going to say, should we change it to degrees, or should we change the degrees to radians because of the units not adding up?
Okay, so remember when, yeah, we were thinking about that yesterday, right? Because I think it was bugging you that one said radians and one said degrees. But when you do secant of it, does it matter?
3 over 2, flip it, 2 over square root of 3, 4 over 9, 4 over 3. It's the secant squared of...
Well, the only thing I would go pause. Well, no, never mind. I wouldn't say pause and think about anything. Yeah, you're right. Okay, so he's saying, so your 30 degrees is that, right? Cosine is the square root of 3 over 2, so this is 2 over the square root of 3, which is 4/3. Good. Yeah, it is. Now, let's start to think about units here. Do you guys know what your units should be? That the spot of light's moving along the shore.
Radians per minute.
The units?
But it's going.
Kilometers
Now, this was
per
moving.
minute?
Yeah, right. Kilometers per minute. Okay?
On the
How are
shore.
we going to get that to come from this? Here's how we get that to come from this. First off, we don't write radians. Radians is sort of like, it's just showing you how far around a circle you're going. So technically that unit kind of goes away. And that's the only thing that's a little bit weird. So this is 3 per minute. Okay? You're just going 3 per minute. And then if you think about this was 5 kilometers, then my kilometers goes right there, and then it does work out. Units-wise, it does work out. Okay? So again, 4/3, and then the 3 cancels with the 3, right? Yeah. 20 kilometers per minute. Maybe later I'll have one of you guys go over the beginning for those guys.
You just splice the videos together.
No, yesterday it shut off. I guess because my storage was getting low. It shut off right before the lighthouse started.
That's too bad. Oh, we're too
Yeah, we missed their song. You guys all have to sing. It wasn't "Don't Stop Believing." What was it?
Anyway, you
And
want
if that's the way.
Put that on.
What you draw a picture of?
A balloon.
Okay.
You didn't even read the whole question, and you're saying we should
I
draw.
read the first word.
A balloon. No, you read the first two words.
Okay, whatever.
Or you'd have just said,
I don't think Oz even a
You shouldn't
word.
draw a balloon, you
It's a
should draw a
letter.
sphere.
Yeah, I
Which you
tried.
did.
I tried,
Form
yeah.
of a sphere.
Because
It's a balloon.
balloons could be shaped like a hot dog.
They
or they could be
could.
shaped like a curly Q, or they could be shaped like a teardrop.
We
or
could
they
be
make shaped like.
Usually a teardrop,
Like
I
an
would say.
hourglass.
What kind of balloon are
They
we
could be
talking
shaped-
about?
So we're talking
The
about the
Mylar-
balloon
the
in the
Mylar
form of a
usually-
sphere that is being inflated at the rate of 10 cubic meters per minute. So how should we write that?
That means the
dV,
per minute.
dt, V for volume
Oh,
is
you guys are awesome.
that
Right.
rate.
Yes, it's d something dt because it's a rate. And what is the something? Because it was cubic meters, it's volume.
Can you start with
Yeah.
a tablet? I'm gonna take space.
You're going to what?
I said around space. and throw me
I
a
thought you
tablet.
said you're going to hit him in the face. I'm
Don't
gonna,
go over.
You're gonna hit me. You're gonna hit it.
I was scared if you went like tomahawk.
It's like
If
a
you were
bird.
like it might have been different. You were like,
this is why they pick me last in gym class all the time.
I was like,
Okay, find
It's like, oh, it's her.
the rate at which the surface area of the sphere, and I guess I should have labeled this with a radius. Find the rate at which the surface area of the sphere is increasing. Now, you guys can use whatever you want for surface area. Like some people would just do S or A. I actually do SA.